In 2003, a rocket launched from Cape Canaveral, Florida. Its destination was Mars, and it was carrying a rover that would achieve the impossible, Spirit. It was not designed to last more than 90 sols, yet it lasted 6 years. Not designed to survive Martian winters, it endured 3. Not designed to survive destructive dust storms, it survived several. And not designed to perform mountaineering, yet again, this pioneering rover did it anyway. With obstacles constantly thrown at it, Spirit kept going and explored the surface of Mars on its mission to find evidence of life on the planet or in its past. I'm Alex McColgan and you're watching Astrum. And in this Supercut, I will take you on Spirit's complete journey both to and on Mars, the trials it faced, and the remarkable discoveries it made. Alongside its companion rover, Opportunity, whose journey I have covered in this popular series, Spirit was part of NASA's Exploration Rover mission, an element of the Mars Exploration Program. This program had 4 science goals. 1. Determine whether life ever arose on Mars. 2. Characterize the climate on Mars. 3. Characterize the geology of Mars. And 4. Prepare for human exploration. Spirit was designed to be a crucial component of achieving these goals, with its main scientific objective being to search for rocks and soil types, then track down clues for any potential past water activity on Mars, a key indicator of life having once been on the planet. As scientists cannot yet go to Mars themselves, robot geologists like Spirit are essential for the success of the Mars exploration program and for the future of human space exploration. To undertake the mission, Spirit's designers armed it with a utility belt of tools. Around 185 kilograms in weight and roughly the dimensions of a golf cart, Spirit was equipped with panoramic and navigation cameras, a miniature thermal emission spectrometer for examining rocks and determining their origins, and 2 180-degree HazCams for observing the rover's surroundings. Meanwhile, on the rover's arm, there was a Musbauer spectrometer and alpha particle X-ray spectrometer for investigations into the mineralogy of rocks and soils, magnets for collecting dust particles, and a microscopic imager for high-resolution, close proximity images of the planet's surface, and a rock abrasion tool for exposing fresh material for examination by the onboard instruments. These were deployed on the robotic arm to get the instruments as close to the material as possible. Spirit's design also incorporated pieces of the fallen World Trade Center's metal, which were used to protect cables on the drilling mechanisms. And as for its name, Spirit, initially known as Mer 2 Rover 2, was named through a student essay competition. The winning entry by 9-year-old Sophie Collis read, "I used to live in an orphanage. It was dark and cold and lonely. At night, I looked up at the sparkly sky and felt better. I dreamed I could fly there. In America, I can make all my dreams come true. Thank you for the Spirit and the opportunity." Now, with its mission, its design, and its name in place, it was time for Spirit to begin its journey. Launching before the Opportunity rover, Spirit took off from Cape Canaveral, Florida on the 10th of June 2003. The spacecraft then went into a parking orbit around Earth as it prepared to embark on its intercept course with Mars. When the time was right, the upper stage of the Payload Assist Module fired and sent the spacecraft into a heliocentric orbit that would lead it to intercept the red planet. But its trajectory wasn't perfect. During its trip through space, Spirit had to course correct 4 times, eventually leading the spacecraft to approach Mars on the 4th of January 2004, after a journey of almost 7 months. But the most dangerous part was still ahead of it. To land on Mars, a spacecraft has to go through EDL, Entry, Descent and Landing, a process that takes a spacecraft hurtling through space at incredible speeds and gets it down to 0 kilometers per hour on the surface of Mars, using only a heat shield, a parachute, some rockets, and an airbag. It's a process that happens so quickly and is subject to so many variables that scientists refer to it as the 6 minutes of terror. And with no time to call back to Earth and recalibrate, the computer has to solve any problems it encounters on the fly. This is what happened. Spirit approached the atmosphere of Mars at 19,000 kilometers per hour. 15 minutes before entering the atmosphere, the lander, inside its protective aeroshell, separated from the cruise stage. As Spirit hurtled towards the planet's surface, the heat shield's temperature rose to 1,600 degrees Celsius, while inside the spacecraft remained room temperature. At an altitude of 4 to 5 miles, the spacecraft slowed down to around Mach 2 and the parachute deployed. 30 seconds later, the aeroshell's bottom heat shield was jettisoned. 10 seconds after that, the rover began to unreel down a tether at a rate of 70 meters per second, all as it raced towards the planet's surface. It was here that the radar began to detect the surface of Mars, and the onboard computer began to determine when the retro rockets would have to fire. At about 5 seconds before the lander smashed into the surface of Mars, the airbags were deployed around it, and, below the parachute, the retro rockets ignited, bringing the lander's speed to 0. The boosters were needed because Mars's atmosphere has less than 1% the density of Earth's, and with that kind of air pressure, a parachute cannot reduce enough velocity on its own. 8.5 meters above the ground, the bridle was cut, and Spirit, complete with its protective airbag covering, fell to the ground at 14 meters per second. This section of the landing was extremely dangerous and vulnerable to chance. If the airbags hit a sharp rock at a wrong angle, the lander would be destroyed. And as it bounced almost 30 times, this was always a possibility. Luckily, no such thing happened, and Spirit rolled to a stop 250 meters from its point of the first impact. Spirit had landed. EDL was complete. The 6 minutes of terror were over. On January 4th, 2004, Spirit was on Mars. The place where it landed was roughly 12 kilometers away from the planned landing zone and inside the Gusev crater, a possible former lake inside an enormous impact crater. A natural target considering Spirit's mission. Once the airbag had settled, Spirit deployed and rolled out onto the surface of its new home and started taking panoramic images that would help the scientists at NASA identify potential geological targets. The images were transmitted using Mars Global Surveyor and 2001 Mars Odyssey, two spacecraft which were orbiting above the surface of Mars. These were the images that Spirit took. The first of these images was the highest resolution color image taken on another planet. This was compiled using 4 PanCam images high and 3 wide, creating a full-size image of 4000 by 3000 pixels. These individual images were taken in black and white, with 13 filter wheels allowing images to be produced in different wavelengths. Back on Earth, these same images were then combined to create the color image you're looking at now, that gives you a view of what it would look like to stand on the red planet. Take a look at what you see. Note the abundance of rocks and the rolling surface in the distance, features that the rover could explore. These are Anderson Hill, Brown Hill, Charler Hill, Clark Hill, Husband Hill, McCool Hill, and Raymond Hill. One area, a circular depression that came to be known as Sleepy Hollow, was a target for the lander due to its ability to provide insight into the interior of Mars. The landing site, surrounded by the aforementioned hills and geologic material, came to be known as Columbia Memorial Station, a name given in honor of the Space Shuttle Columbia disaster where 7 astronauts lost their lives. Spirit immediately began busying itself by exploring Sleep Hollow Crater, an area 9 meters wide and only 12 meters from the lander. However, it wasn't long before something threatened to derail the mission altogether. On the 21st of January 2004, or Sol 17, NASA's Deep Space Network abruptly lost all comms with Spirit. The team at NASA was perplexed. The following day, they received a beep through the network, which meant one thing: Spirit was receiving transmissions, but had determined that it was in a fault mode and would only respond to commands sporadically. This was a serious anomaly, but if it was a software issue or memory corruption instead of a hardware issue, it was fixable. Ordering Spirit to transmit engineering data, the team discovered that an error in the rover's sleep mode had caused it to waste battery and overheat. Issues that could destroy Spirit if they were not rapidly fixed. This was further complicated when, on Sol 20, Spirit ignored the command "shut down, damn it" until from the team, which attempted to cause it to suspend operations. Time was running out. One theory about the rover's issue was that it was stuck in a perpetual reboot loop. Spirit was designed to reboot if it detected a fault, but if that fault occurred during its reboot process, then the rover would reboot forever. Determining that the error was in the flash memory, the team used a design feature that allowed the rover to boot without utilizing the flash memory, which successfully broke the reboot cycle. Alongside this, they discovered that there were too many files on Spirit's file system, which was causing issues with Spirit's operations. Luckily, most of these files were unneeded in-flight data and could be deleted, which they promptly did. They even reformatted the entire flash memory system. The result? On the 6th of February, Sol 32, Spirit was back online and free to explore the surface of Mars. But although it had already traveled across space, through the atmosphere of Mars, and survived the landing and a critical malfunction, its adventure was only just beginning. For Spirit and its instruments, Martian rocks were more than just targets to grind. They were time capsules that offered a glimpse into the planet's environmental past. The question for Spirit then was which capsule to open. One rock, named Sashimi, was close by and a straightforward drive, a tempting target, but there was a hitch. The surface of Sashimi was dusty, which would lead to Spirit's observations becoming obscured. The rock was also pitted, making it a poor match for the rover's grinding tools. Luckily, there was another option. Named Adirondack, this rock was roughly the size of a football, had a dust-free, flat surface, and a high level of cleanliness. It would be a trickier drive to get to than Sashimi, but such a good match for Spirit's tools that it presented an irresistible target. Venturing out into the vast Gusev crater, Spirit turned 40 degrees in short arcs for just under 1 meter, then turned to face the rock, finishing its journey with 4 short straightforward moves of just under 2 meters. This might sound specific, but for Spirit, navigating through the rocky terrain of the Gusev crater, this is how careful it had to be. The enormous Gusev crater, 166 kilometers in diameter, is roughly 3 to 4 billion years old. One theory, based on imagery and mapping, suggested that Gusev was an ancient lakebed sourced from the Ma'adim Vallis, a 700 kilometer long Martian outflow channel, much larger than Earth's Grand Canyon. This theory was one important possibility that Spirit had come to investigate. The rock abrasion tool, which we mentioned earlier, was Spirit's grinding and brushing tool. It was 10 centimeters long, and to take rock samples, it used a wheel coated in diamond dust and resin, which spun at 3000 RPM, giving the rat the ability to drill a 45 by 5mm deep borehole into rocks. Alongside this, the rat had 2 brushes that removed dust from the boreholes and gave the scientist the ability to make closer inspections. Astonishingly, for a machine that performed rock grindings on the surface of another planet, the rat only consumed about 30 watts of electricity, which is crucial given how conservative Spirit has to be when rationing its power consumption. Once the machine had cut the Martian rock, it provided Spirit's other tools with a smooth, clean surface that could be used for precise observations, such as the rover's microscopic imager that helped determine a rock's composition. Before performing any grinding, Spirit returned microscopic images, as well as Musbauer spectrometer readings of Adirondack. These were unprecedented readings, as no investigation like this had ever occurred on Mars or any other planet. These readings suggested that Adirondack contained minerals composed of magnetite, olivine, and pyroxene, not dissimilar from Earth's volcanic basalt rocks. But to confirm this, Spirit had to cut into the rock. On the 6th of February, its 34th sol on the planet, Spirit used the rat on Adirondack. Simply breaking open a rock might sound mundane, but remember how far from Earth Spirit had travelled to be able to do this. Not only that, but this was the first time humanity ever performed a rock abrasion on another planet to more easily identify its composition. Spirit was making history. Using the instruments on the freshly exposed material, it helped confirm the suspicion that the rock was volcanic basalt, and provided intriguing insights into the makeup of Mars. Spirit teased out the secrets written in rock. Hopefully Mars was using clear language and correct grammar, but in scenarios where it's struggling to get its point across, maybe Mars would have benefited from the sponsor of today's video, Grammarly. Grammarly is an AI writing partner that improves your writing and can tailor your style to any audience by offering writing suggestions that customizes the entire tone of your work, professional, casual, and everything in between. Mars might not be using emails, reports, presentations, or papers, but you likely do, and Grammarly can enhance your work to get your point across in the best way. It also saves you time by replacing hours of rewrites with just a few easy clicks, so you can focus on what you'd rather be doing, like checking Martian rocks for ancient signs of life. Grammarly integrates right into the everyday apps all professionals use, so it's really intuitive, and best of all, it's free to use and try out. So why not follow this link and search for grammarly.com/Astrum03 to try Grammarly for free. I am a big fan. But what did Spirit learn? Well, Adirondack was a remarkably well-chosen target because it turned out to represent a typical rock found on the plains of Gusev crater. Spirit's instruments showed that Adirondack, and later other Gusev rocks, were indeed filled with pyroxene, plagioclase, olivine, and magnetite materials. These made the rocks picritic basalts, similar to earth-bound rocks called basaltic komatiites. Adirondack in particular has been ever so slightly altered, possibly as the result of thin films of water interacting with the rock. These small quantities of water may have induced mineralization. One key giveaway is that Gusev rocks such as Adirondack were easier to grind compared to similar rocks on Earth. It was time to move on. On the 5th of March, Spirit trekked to Humphrey Rock, where it found some striking hints of water history on Mars. Humphrey was a dark volcanic rock, about 60 centimeters tall, with bright material in its interior crevices, alongside cracks that appeared to be minerals crystallized from water. These were revealed when Spirit used its rat to scrape away the rock's surface by 2 millimeters. These materials were another signpost that water did indeed exist on Mars, and either interacted with Humphrey after it formed, or was contained within it. This was a huge step forwards, potentially discovering the answer to one of the Mars exploration program's key questions. Did life ever arise on Mars? If we are to ever colonize Mars, answering this question is crucial. Spirit's investigation wasn't destined to end at Humphrey Rock. Our rover had more work to do. On Sol 65, March 11, 2004, Spirit journeyed to an impact crater known as Bonneville Crater, home to Spirit's heat shield, which was jettisoned during landing. Bonneville Crater was located within Gusev and was not particularly large. It had a diameter of roughly 210 meters, a depth of 14 meters, with a rim that rose 6.4 meters above its surroundings. Given this low depth relative to its crater, Bonneville was likely a secondary crater, formed from the ejecta of a much larger impact elsewhere. It was also relatively pristine and not subject to any water erosion. However, As interesting as the crater might have been in theory, once Spirit reached the crater's edge, no interesting target rocks could be found, so the rover avoided descending into the crater's belly. Instead, Spirit headed towards the Columbia Hills, which were briefly glimpsed from the Spirit's landing site. This journey brought Spirit into contact with another crater. On Sol 118, already outlasting its original mission target, it reached La Hontan crater, which was even smaller, at 55 meters across and 9.1 meters deep, but it posed a serious risk to Spirit. On the southwestern side of La Hontan was a long sand dune, a threat to the stability of the rover's wheels. Spirit couldn't risk coming into contact with this and toppling over, so the dune was avoided. Even with obstacles like La Hontan's dunes, Spirit's path to the Columbia Hills was a relatively straight line. Spirit was directly controlled by engineers when the terrain became more complex, but otherwise was largely safe to travel autonomously for his lonely journey across the dunes of Mars. By Sol 159, Spirit had reached the foot of the Columbia Hills, at a location called West Spur. As it got closer to the hills, foreboding signs indicated that the rover was beginning to age. Spirit's right front wheel began drawing up to 3 times as much current as the other wheels. This meant that the wheel could be stuck, and moving it required more effort, draining Spirit's limited energy and heating the motor to an inoperable degree. What was the cause of this? One possibility was that debris could have lodged into the wheel's mechanism, preventing rotation. Another was that congealed lubricant might no longer be spreading over the wheel's moving parts. Ingeniously, Spirit had heaters in the wheel to solve this very problem. But without knowing the true cause of the issue, Spirit needed to minimize damage in the short term. Moving forward, Spirit started using the front wheel sparingly, leaving the brunt of the effort to the other 5. That said, drag from the front wheel would have to be accounted for, and in instances where climbing steep slopes or difficult terrains became necessary, Spirit would have no choice but to use all 6 wheels. On Sol 174, Spirit began a 3,000 meter tune-up to help itself to get in better shape for its oncoming missions, designed to help it get through the next 3,000 meters. One fix was a front hazard avoidance camera calibration. This was necessary, as Spirit had begun to experience a 2 to 3 centimeter inaccuracy in predicting the actual location of targets. To help fix this, Spirit used various arm poses and images to refine its ability to target objects with its stereo hazard avoidance camera images. This was followed by a front wheel diagnostic and lubrication to help fix its rotation, as well as visual odometry tests to help Spirit navigate with greater speed. The tune-up was also where Spirit had its first, well-deserved deep sleep. This mode left the rover depowered overnight, allowing it to save energy spent on survival heaters and electronics usually present when it was napping. This was essential if Spirit was to save energy over its coming sols on Mars. But deep sleep wasn't without its dangers. As the survival heater was powered on, there was a risk Spirit's mini thermal emission spectrometer instrument would not power back on. So Spirit undertook 2 potentially final observations with the instrument before finally powering down. Throughout this, Spirit's solar panels were tilted towards the winter sun, conserving as much energy as possible and helping them overcome the interference from the setting sun and increased levels of dust. Once the tune-up had ended, Spirit spent the following sols studying many rocks across the Columbia Hills, such as the rocks named Clovis, Ebenezer, and Lutefisk. On Sol 188, Spirit found a solution to its issues with the front wheel. A solution more creative than diagnostics and lubrication. It started driving backwards. This helped Spirit improve performance and extend the lifetime of the front right wheel's motor. An example of the simple changes and clear thinking that kept the rover operational for so long. A solar conjunction delayed Spirit, but once it was over, the rover journeyed to the summit of Husband Hill, which sat around 107 meters higher than the surrounding plains of the Gusev crater. Aside from being home to views of Gusev, it was flanked by a beautiful albedo feature on its south side, rich with dark rolling sands, not unlike a dune on Earth, which gives Mars its distinctive texture when viewed from space. And now, by Sol 344, Spirit was in a good place to continue its mission on Mars. 344 sols. That's an incredible achievement for a rover that was only meant to survive 90. And yet, Spirit kept on going and going, providing more and more data for scientists. But how much longer could Spirit last? The days marched on. Spirit entered the week of its first anniversary of landing on Mars. To celebrate, it began studying a rock named Champagne on the slopes of Husband Hill. Yes, even robots need to party. And as a robot, it enjoyed its champagne in the most socially unacceptable way possible, alone and with full use of its science payload. After these measurements, however, the Spirit team confirmed the existence of a minor short circuit of 0.1 volts. This short wouldn't affect the day-to-day operations of the rover, but it would make Spirit more vulnerable to subsequent damage. Otherwise, Spirit was doing well. The team continued to traverse up the soft, dusty slopes in increasingly complex maneuvers to ensure that our rover didn't become trapped, a traverse complicated by increased dust in the atmosphere, reducing the sunlight reaching Spirit's solar panels. Some of that dust had settled as a coating layer on the panels, which meant that Spirit's team needed to be extremely careful with how they planned their route and power consumption. Nevertheless, en route to Larry's Lookout, a point on Cumberland Ridge, Spirit analyzed two small rocks of interest, Peace and Alligator, before imaging a far larger rock much further away, but one the rover can never hope to reach: Phobos, Mars's largest moon, a 26-kilometer wide satellite that is due to impact Mars's surface in 10 million years. With its imaging task completed, Spirit ventured forth across Cumberland Ridge, but only briefly before it made an unplanned stop. NASA engineers noticed that Spirit had curiously churned up an intriguing area of soil during its maneuvers named Paso Robles. But what was it about this area of soil that captured NASA's interest? Paso Robles was found to contain incredible levels of salt and high levels of phosphorus. We're trying to work out what this means, but clearly with this much salt around, water had a hand here. A stunning and fortuitous find about the history of water on Mars, one that preceded another unexpected discovery through failure that we'll reveal later. To complete its journey to Larry's Lookout, Spirit deftly reversed large sections, which helped to relieve pressure on the failing front wheel. Instead of moving forward and pushing the struggling wheel into the ground, reversing the rover up the slopes dragged the wheel across the surface, saving Spirit energy. From Larry's Lookout, Spirit took this panorama on Sol 413. To the right, we can see Spirit's tracks. To the left is a rocky outcrop which is part of Cumberland Ridge. Beyond that lies the Tennessee Valley. This image was made with 108 frames, each composed of 5 images taken through Spirit's different filters, which creates an approximate true color image. In the center of the image, 200 meters away and 45 meters higher in elevation, is the summit of Husband Hill, Spirit's next destination. This was to be a difficult and energy-consuming journey, but Spirit had a chance encounter that greatly improved its prospects. Mars's dust devils on Sol 421 swept over the rover, clearing a year's worth of dust buildup and increasing its solar panel efficiency from 60% to 93%. Over the next 160 sols, Spirit tackled its way to the top. The increase in energy supply meant that Spirit was able to upload its data every sol with the Odyssey orbiter, allowing the team to capture lots of information en route, including on samples Paso Robles 2, Big Clod, Paso Dark, Methuselah, Keystone, Pittsburgh, Independence, and Franklin, without filling up its limited storage. On Sol 581, Spirit reached the first summit of Husband Hill, but our hard-working rover had no intention to stand idle. It took a 360-degree panorama, composed of 653 images, for the first time imaging the entire deck of the rover in a panorama. Look how clean those panels are! During the nights on the top of Husband Hill, Spirit also imaged both moons, Phobos and Deimos, in order to measure their orbits more accurately. In the panoramic image, McCool Hill and Raymond Hill are off in the distance in the center. McCool Hill was to be its winter destination, an area where Spirit could park up and angle its panels to the sun to maximize its energy capture over the darker months. But it never reached it. So let's continue Spirit's journey to see what it can achieve in its final 2.6 kilometers of life. On the descent of Husband Hill, Spirit was able to collaborate with the Hubble telescope to help calibrate data with atmospheric opacity readings, a sky survey, and calibration target readings. This helped with the accuracy of Spirit's measurements. Incredibly, Spirit's capability increased several times in its life, despite being 142 million kilometers away from its team of engineers. The multitasking rover installed an update as it was climbing Husband Hill, giving it the ability to drive sections autonomously, and another on Sol 1067 allowed Spirit to decide if and when to upload images, and whether to extend its arm to examine rocks. Spirit gained independence as it matured. There was one decision that NASA controllers still took on the descent of Husband Hill though: which rock to analyze out of a choice between two, Comanche and Miami. Comanche was chosen, and it turned out to be a rich subject to analyze. On Sol 690, Spirit discovered that Comanche was 1/4 magnesium iron carbonates, around 10 times higher than any rock previously analyzed on Mars. Carbonates are important in further understanding the hydrological history of Mars, as they are formed in the presence of water but dissolve by acid. So their discovery in high levels suggested that more neutral and hospitable bodies of water existed that could have been home to primitive life much earlier in Mars's history. A great discovery, but Spirit continued on tirelessly, and it reached its next checkpoint on Sol 744, Home Plate. Home Plate features layered and weathered rocks, including this feature found on the outskirts. It's hard to imagine this being shaped by anything other than flowing water. But it was the flow of time that was shaping Spirit. The rover was charging towards the north-facing slopes of McCool Hill in 2006 when one of its wheels failed. Exhaustive tests back on Earth at the JPL test facility, replicating the failure, could not get the wheel moving again. Spirit was now only making progress by dragging the locked right front wheel. Martian winter was coming too, and as the light fades, so do Spirit's reserves. With these two factors combined, NASA made the call to abort the drive to McCool Hill in favor of Low Ridge Haven. The rover found a spot with an incline of 11 degrees, which was sufficient to see Spirit make it through another Martian winter. For around 8 months, Spirit remained on the ridge, taking images of its surroundings. In one of the images, engineers spotted 2 subjects that were possible iron meteors. These were given the names Zhongshan after the Chinese Antarctic base, and Allen Hills after an area in Antarctica where several Martian meteorites have been discovered, including the most well-known and noteworthy of these, ALH 84001. Found in 1996, NASA scientists suggested that this Martian meteorite may contain fossilized extraterrestrial life, and released this image you may recognize as it became front-page news the world over. Once the Martian winter was over, Spirit had far more energy to use, and it ventured out once again. In March 2007, Spirit unwittingly excavated a surprising discovery. In the soft and red Martian soil, Spirit's failed wheel gouged the Martian surface, exposing bright white silica. Not evidence for life per se, but the next best thing, evidence for potential life. In our video on the origin of life, we talked about deep sea vents and areas where hot gases and material from below the crust meets the Earth's surface. Some create the potential for life to start. Others offer life a haven for growth. NASA believes that the silica deposit was made in one of two environments. Either hot spring deposits, where hot water dissolves silica in one place and then deposits it elsewhere, like hot springs or geysers, or alternatively, acidified steam blasting existing rocks, stripping them of much of their minerals, leaving mostly silica behind, areas known as fumaroles. Whichever it was, both environments are very supportive of microbial life on Earth. Incredible to think, if Spirit had not malfunctioned, if it and NASA had given up too early, this discovery would never have been made. Spirit spent the next few months circling home plate, and in June 2007 received another life-saving spring clean of its solar panels. Spirit boosted its power generation from a dip of 120 watt-hours back to over 600. On November 6th, Spirit navigated to the western side of home plate and took another panorama. NASA published this photo as an astronomy picture of the day, which, on first inspection, looked like every other photo taken of the Martian landscape. But it was soon to receive worldwide attention. Can you spot it? Hidden in plain sight is a suspected humanoid life form. Let's zoom in to what was dubbed Little Bigfoot. On the right of the image, we can also see Spirit's tracks from Husband Hill. We are now a few hundred meters away from the end of Spirit's journey. Martian storms had been increasing in recent months, leaving the solar panels heavily covered with dust, as well as blocking up to 99% of the light through the atmosphere. Survival was becoming harder, and operations were now much reduced from its peak. The aging Spirit was generating only 128 watt-hours, which is less than the 150 it requires to keep itself warm. If the heating were to fail, then the rover's components would eventually fail too. Two small cleaning events took the energy output of the solar arrays to 372. This gave the rover enough energy to charge its batteries and begin to move again. But the flow of time is always cruel. Spirit began to experience unexplained memory gaps in April 2009, with the rover now only 4 meters away from its resting place. On Sol 1892, Spirit hit incredibly soft, dusty soil at a location named Troy, where Spirit would make its last stand. Underneath its wheels was jarosite, which is a mineral of iron sulfate. Jarosite has remarkably low cohesion, meaning that achieving enough traction to move was proving impossible. Despite efforts by the JPL back on Earth to explore techniques to escape the sand trap, no progress was made. On Sol 2155, NASA reclassified the mission as a stationary research platform. While there, our rover took measurements of the atmosphere and several more images, including its last panorama from Troy. Spirit was still able to perform soil studies and extraction tests because the functionality of its arm was still excellent. Spirit needed to have a busy research schedule to use the power it was generating to maintain good battery health. But the final winter was approaching for Spirit, and it was a bitter one. Over the next few months, the power generation continually dropped, and by Sol 2196, it was again down to the critical 150 watt-hours. Sometime on Sol 2208, it is believed Spirit suffered a low power fault. On a lifeless and quiet planet, Spirit's end was never going to be dramatic, but that's not to say Spirit went gently into that good night. Now forgotten by many who watched Spirit's landing, it came to rest on the edge of home plate, alone, with 2 broken wheels, a drained battery, and a legacy of scientific discovery. In its life of 2,208 sols, Spirit journeyed 7.7 kilometers and transferred over 128,000 images back to Earth. Its mission was an overwhelming success, achieving its objectives to further the understanding of the history of water and the chance of life on Mars. Its name lives on in the name of asteroid 37452, Spirit, and the Perseverance rover is carrying its memory today, with this a family portrait of the Mars vehicles. Spirit's story is one of overcoming. Both the Spirit and Opportunity rovers lived up to their names given to them by that 7-year-old girl called Sophie. Names inspired by the struggles and promise of her own childhood. So, it's fitting that as the Spirit's internal heaters turned off, as it froze under the Martian starscape, the rover's story came full circle and found its end right where it began with Sophie's. It was dark and cold and lonely. At night, I looked up at the sparkly sky and felt better. I dreamed I could fly there. Thanks for watching. I really want to give a huge thank you to our astronauts on Patreon. It's really becoming a thriving community, and I've loved reading all your messages and comments over there. If you'd like to join in, then you can visit the link in the description to become an astronaut and bring the channel more stability than the algorithm. When you join, you'll be able to watch the whole video ad-free, see your name in the credits, and submit questions to our team. Meanwhile, click the link to this playlist for more Astrum content. I'll see you next time.